Good morning. Welcome to the very last assignment. All you need to do is print out these notes that were attached in the post or have lined paper and you're writing down every single thing that I'm writing. As long as you have all the notes written down and you do the assigned on your own problems, then you get full credit for today's assignment. So we're just going to be working with radicals today. We've done these before in the beginning of the semester. You might have done it with your teacher in the first semester if you didn't have me. But for the last day, we're just going to be practicing radicals because if you're moving on to pre-calculus, you're going to be doing this in the second half of pre-calculus a lot. So in the first part, we're going to review simplifying radicals, and we're going to reduce by removing perfect square factors. So if you don't remember the perfect squares, those are the numbers that when you take the square root, it's a whole number. So that's like 1 times 1, which is 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and of course you can go further. I'm going to stop my list here. So those are the perfect square factors that we're going to split these into. So let's start with A. When you have multiple things beneath a square root that are being multiplied or divided, you can kind of just split them apart. So square root of 100n cubed is the same as the square root of 100 times the square root of n cubed. And we're going to talk about what to do with the variable and the exponent, but first I'm just going to do the square root of 100, and that's just 10. By the way, that little dot is not a subtraction sign, it's a multiplication sign. It means multiply, okay? So what you're going to do for your variables and your exponents is you're just going to split it into n to the first, so you're going to take 1 out. That way you're left with the largest even exponent that fits into 3, and then there's 1 left over because you can only take the square root of even exponents, and when you do that you just cut it in half. So we have 10, and then you have the even exponent, so when the square root of n squared is just n, and then anything left over. So we're not going to have decimal exponents or fractional exponents, so I'm just going to keep that as root n. So this square root of 100n cubed is the same as 10n root n, and that's all done. Okay, we're going to do the same thing for the rest of the problems. We have 2 more of just the multiplication. So in letter B, it's the same thing as 120 times root b to the 4th. The 120 is also beneath the root. 120 is not a perfect square. If you take the square root of 120, you get a decimal. So you need to find the largest perfect square that fits into 120. That is a factor of 120. That way we can just split it. So you can use a calculator. I know that it goes into 4. There might be a bigger one. Maybe not. I'm just trying. I think it's probably going to be 4. I don't know if I did that yet, but I think it's just 4. So 4 times 30. And since my b to the 4th, since the exponent is already even, I don't have to split it apart. You only have to do it when it's odd, when you take the 1 out. Okay, so the square root of 4 is 2. Square root of 30 is a decimal, so I'm just going to keep that. And the square root of b to the 4th, you just have the exponent. That's b squared. Make sure anything that you do take the square root of, it has to go in the front, just like we did here. If you take it out of the square root, it goes in the front. Don't keep it beneath the square root still. Okay, now we're on to letter C. That's the same as root 32 times root x. And again, if you take the square root of 32, it's a decimal, so we have to split it apart. And that's the same, since that's a smaller number, I can do it without a calculator. So that's the same as 16 times 2. That's the largest perfect square is 16. That is a factor of 32. So the square root of 16 is 4. The square root of 2 is a decimal, so I keep it. And the square root of x, x to the first, but we talked about what to do with just the first. I don't want decimal fractions, so I'm just going to keep the x beneath the square root with the 2. So 4 root 2x is my final answer. Let's start some division ones. So it's pretty much going to be the same thing. You're going to try to split it. You're going to divide if you need to, and then keep the square root. So let's try letter D. Again, if you have division in the square root, it's the same thing as splitting everything apart. My 4 exponent is even, so I'm just going to keep it. I'm going to split apart my 18, and that's the same as 9 times 2. And then my square root of 200, the largest perfect square that's a factor, is 100. It's 100 times 2. So I have a root 2 in the numerator and a root 2 in the denominator. Something divided by itself is 1, so those cancel. And now I'm just going to simplify. The square root of 9 is 3. Whoops, don't have lead. The square root of x to the 4th is x squared because you just have the exponent. And the square root of 100 is just 10. So that's done. Same thing for letter E. Oh, there's an s in the numerator and an s cubed in the denominator. Who remembers how to divide with exponents? I'm going to simplify that first. So that's technically an s to the first. I'm going to use this lead pencil. So when you divide with the same base, you subtract the exponents. And then when it's larger in the denominator, that's where you keep your answer. So 1 minus 3 is negative 2, but to make it positive, right, because we don't want negative exponents, we keep the exponent where the larger number was, which is the 3. So that's the same as 28 over s squared. Okay, I'm going to split apart. 28 is the same as 7 times 4. So 4 is the largest perfect square. That is a factor of 28. And I'm just going to take the square root of my s squared already. Cut the exponent in half and you just get s. Square root of 4 is 2. Square root of 7 is a decimal over s. All done. Okay, I want you to try the same thing for letter F. So you can divide the a to the 5th over the a to the 7th. You can split apart your square roots, and then you can take the square root of whatever you can. Okay, so now we're just going to move on to operations with radical expressions. So you can use the distributive property with radical expressions. Here we're subtracting and adding. So if you have 2 root 5 and you're subtracting 4 root 5, you're just combining like terms because they both have a root 5. So you're just doing the operations on the coefficients. So that's 2 minus 4 is negative 2 root 5. Like if you had 2x minus 4x, that would be negative 2x. It's the same idea. Okay, so for letter B, they're not like terms, like we had both of them be root 5s in letter A, so we just have to do some simplifying. Same thing up here that we did with splitting apart our radicals. So for root 2, let's split apart our 18 because that has factors. So the largest perfect square that's a factor of 18 would be 9. 9 times 2 under the square root. I'm going to simplify that because root 9 is 3. And now they are like terms because they both have root 2. So 4 root 2 plus 3 root 2 is 7 root 2. Let's try one more. So 3 root 3 can't be simplified anymore because the only factors are 1 and 3. 75 can be split into 25 times 3. I'm going to simplify my root 25 into 5, and then I keep my root 3. Now they're like terms. 3 root 3 minus 5 root 3 is negative 2 root 3. You're going to do the same thing for letter D on your own. So try to split apart your root 12 and your root 108 into the largest perfect square factor. Simplify that square root, and if they're like terms, you can add them. So far you have F and D to do. So you should be pausing the video if you want to do that right now. Okay, the last thing that we're going to do is rationalize the denominator. So when dividing radical expressions, the denominator should not be left with a radical. It's a rule in math. Rationalize the denominator by multiplying the numerator and denominator by the radical in the denominator and simplify. That's a lot of words, so I'm just going to show you what it is that you need to do. In math, we don't like leaving square roots in the denominator. Kind of the same idea as not leaving negative exponents in our answer. So in letter A, we have a radical over the whole fraction. So you learn that's the same thing as splitting the radical between the numerator and the denominator. And I'm just going to simplify root 25, and that's 5 over root 3. So the issue here is you can't leave your answer with a radical in the denominator. So we're going to get rid of it by multiplying the numerator and the denominator by that radical. So I'm going to multiply the top and bottom by root 3. You're allowed to do this in math because root 3 divided by root 3, something divided by itself, is 1. If you multiply something by 1 in math, it doesn't change the value, it stays the same. It changes the format of it because we're multiplying the top and bottom by root 3 over root 3, but it doesn't change the value. It's just going to convert it so that the radical is no longer in the denominator. So just multiply the top and bottom by the radical in the denominator. That's the rule here. Okay, now I'm just going to multiply across for my fraction. So 5 times root 3 is just 5 root 3, right? It's not 15. It's not root 15. If they were both roots, it'd be root 15. They're not like terms that they can be combined. So 5 root 3 is the same as just 5 times root 3. Root 3 times root 3 is root 9, right? Those are like, so you just multiply the 3's beneath and keep the radical. Root 9 is the same as 3. 5 root 3 over 3. So root 25 over 3 is the same as 5 root 3 over 3. This is just the proper format because the radical is gone. I'm going to do the same thing here. I'm going to split this. I have some simplifying to do before multiplying, before rationalizing, because 75 can be split apart into 25 and 3. So make sure you're keeping that same mentality where you're trying to split apart your roots. Root 25 times root 3. And then that's the same as 5 root 3 in the denominator because root 25 is the same as 5. Okay, now I can rationalize. Rationalizing is when we're trying to get that radical out of the denominator. So I'm just going to bring this down. We get rid of it by multiplying the top and bottom by the radical in the denominator. So I'm going to do the same thing as I did in letter A, and I'm going to multiply the top and bottom by just the root 3. And it'll get rid of the radical in the denominator. Okay, so root 2 times root 3. Since they're both roots, you can just combine them with multiplication. That's root 6 over. And then 5 times root 3 times root 3. Well, you keep the 5 because it can't be multiplied with a radical. You just keep it in the front. Root 3 times root 3 is root 9. And don't forget to simplify. Root 6 can't be split into perfect squares. 2, 3, 1, 6 are not perfect squares, so that's going to stay. And then 5 times root 9, well, that's 5 times 3. So my final answer is root 6 over 15. All that work. So this is the same as root 6 over 15. This is just the proper way to write it. Going to do the same thing here. My root 6 can't be split apart into a perfect square because the only factors are 2, 3, 1, and 6. So I'm just going to go right ahead and rationalize. Multiply the top and bottom by root 6. 4 times root 6 is 4 root 6. Root 6 times root 6 is root 36. As you can see, multiplying the radical by itself always gets rid of the radical. It always does. And that was the whole point. Root 36 is the same as 6. And I just need you to simplify more because now you have 4/6, which is the same as 2/3. Always reduce your fractions. We're going to do one more, and then you're going to do these two on your own. So root 10. 10 can't be split apart into two perfect squares because the only factors are 2, 5, 1, and 10. So I'm just going to rationalize. Multiply the top and bottom by root 10. So 5 times root 10 is 5 root 10. Root 10 times root 10 is root 100. Simplify further because root 100 is 10, and don't forget to reduce your fractions. I have 5/10, which is the same as 1/2. You don't have to put the 1 if you don't want to. So you can write 1 times root 10 over 10 or root 10 over 10. So root 10 over 10 is the same as 5 over root 10, but root 10 over 10 is the proper way of writing it. So you're going to do the same thing for E and F. You're going to rationalize this one, and you're going to rationalize this one. So be careful when you're multiplying. You can only combine the numbers when they're both radicals or they're both just numbers. So like root 3 times root 3 is root 9, but you can't say that 3 times root 3 is root 9, okay? So just use these examples to complete E and F. When you're done, upload both sides of these notes to the posting on Google Classroom. Let me know if you have any questions. And congratulations, because this is your last assignment if you're not making anything up or if you don't have any missing assignments. Bye.